Okay, this is a pre-algebra lesson on probability. So probability is, by definition, the number of favorable outcomes, the number of favorable things that can happen over the total possible outcomes or the total possible things that can happen. For example, if I have a die, one of a pair of dice, so just one cube has a 1, a 2, a 3, a 4, a 5, and a 6. If I roll that one time, and I'm asking for the probability that I'm rolling a 6, let's say, is simply the probability of a 6. So probability of a 6 is equal to, there's only one 6, and there's 6 possibilities, so it's 1 out of 6. Now let's say I have the probability of rolling, let's say I win if I get a 5 or a 6. So probability of 5 or 6 is going to be 2 favorable outcomes over 6 possible outcomes. And I can reduce that. It's a fraction, it's a ratio. I can reduce it to 1 out of 3. So the chances of getting a 5 or a 6 is 1 out of 3. Um, now, um, let's say the probability of you're flipping a coin and the probability of getting a head. The probability of a head is 1 out of a possible of 2. It could be heads or tails, so 1 out of 2. So that's the probability of a head. Let's say I'm rolling dice, but this time I have 2 dice. That makes it a bit more complicated because I have a bunch of different combinations. We went through this in class, but I have it here. I can have a 1, a 2, a 3, a 4, 5, 6 on the one dice, and then a 1, 2, 3, 4, 5, or 6 on the other one. If I look at all those reveal a combination. A 1 and a 1 is going to give me a 2. 1 and a 2 is going to give me a 3. And you see we get this nice pattern here. 2, 3, 4, 5, 6, 7 on top there, and so forth. Well, let's say I roll both dice, and let's say I win. I'm betting I'm getting a 7. Well, to determine that, we look at all the combinations of 7. And there's quite a few here. There's a 7 there. 7, 7, 7, 7, 7. If we count all those, we get 1, 2, 3, 4, 5, 6. Out of a possible, so the probability of a 7 with 2 dice is 6 out of, if I count all of these, not the bold-faced ones on the outside, but all of these, I get 6 by 6. There's 36 possible. So it's 6 out of 36. And so that is the odds, or not the odds, I'm sorry, the probability of getting a 7 is 1 out of 6. The probability of, let's say, a 3 is much less, because here's my only 2 combinations of 3. So my probability of getting a 3 is 2 out of 36, or 1 out of 18. We can also do this with cards. It's always important to remember this because you'll often see math problems with a deck of cards also. For a deck of cards, it's important to remember that there's 52 cards in a deck, not counting jokers. And there's hearts, and there's diamonds. I'll put a D for diamond. And there's clubs, and there's spades. So those are the 3 different types of things. Hearts and diamonds are red, and clubs and spades are black. And for each of these suits, there's a 2, 3, 4, 5, 6, 7, 8, 9, 10, in a Jack, King, or, well, Jack, Queen, King, and an Ace. So there's 13 cards. 13 times 4, by the way, is 52. If I'm looking at the probability of, let's say, getting the probability of getting a ace of diamonds. So ace of diamonds, and the probability would be 1 out of 52. The probability of just any ace would be 4 out of 52, which is 1 out of 13. So you can see there, I won't spend too much time on this, but there could be a whole lot of different combinations of problems that people can get using the deck of cards. Some factors to remember, though, are that 4 times 13 is equal to 52. That'll be helpful. Now, the other major thing besides probability, the definition of probability, is there's definition of odds. So, for example, in horse racing, if you ever gone to the racetrack at Del Mar, which is pretty close to us, you will see that they post things by odds. And odds are similar, but a bit of a different definition that gives you different outcomes. So the odds are the number of favorable outcomes over the number of unfavorable outcomes. So the top is the same, the numerator is the same, the denominator is unfavorable outcomes. So, for example, the odds of one die of tossing it and throwing a 6 are 1 out, and so one favorable outcome, I win on 1, whatever I pick, the 6, I win on the 6, and if I get a 1, 2, 3, 4, or 5, I lose, and there's 5 of those possibility. So the odds of the odds of getting a 6 on one die is 1 out of 5. The odds of getting a 7 with 2 dice is, I guess, 7, 7, 7, 7, 7, 7. So that part's the same, but it's going to be 6 out of, I lose on any of the other ones. So there's 36 possible, but I win on 6 of those. So there's 30 left. So it's 6 over 30. Or if I reduce that, the odds of getting a 7 can divide top and bottom by 6, or 1 out of 5. That's 2 dice and getting a 7, for example. Of the probability of getting, or not the probability, the odds of getting a 3 would be 2 out of 34, or 1 out of 17. The odds, again, odds, is of getting a heads, flipping a coin, is 1 over 1. Okay? So that's, sometimes in normal language every day, sometimes we use odds when we really mean probability and vice versa. But in math, there's very specific definitions. So with that, we'll go ahead and end this video.